Alright, boys and girls, I'm going to do a quick review video over lesson 7.1. So this is when we were solving linear systems by graphing. I'm not going to look at the warm-up with you, I'm just going to get right to the information. So today's goal was I will solve linear systems by graphing. The biggest thing that we're learning is linear systems is when we have more than one linear equation. So like we see x plus 2y equals 7. We know that's a linear equation, and we know that 3x minus 2y equals 5 is a linear equation. What we're looking for now is a solution of the system of linear equations in which that ordered pair would be the answer to both of our linear equations. So what number or what coordinates would solve x and y for both x plus 2y equals 7 and 3x minus 2y equals 5? Okay, the way we're going to work on it today was by graphing. So, I want to highlight this thing. Here's the key. Sorry about that noise in the background. It's my kid. But the one way is by graphing. And we're going to find when we graph where the two lines intersect. Remember, when we go to graph, what we'll want to do is make each line y equals mx plus b. Bennett, get off it, please. And remember, that way we can say what m is our slope and b is our y-intercept. Alright, so on example 1, I've already done these, and I'm just going to show you. It said, tell whether the ordered pair is a solution of the linear system. So I had negative 3 and 1. So I input negative 3. Actually, I should have done it this way. I'm sorry. I'm going to say negative 3, and I'm going to say 1. And of course, those are my x and y. And so I'm going to input them in. So negative 3 goes in for x right here. On this equation, I'm just doing this so I can use the same highlighter. And when I go to green for y, and for here, y. Alright, so what I did on the first equation, I had negative 3 plus 1 equals negative 2. Well, negative 3 plus 1 is negative 2. So negative 2 minus negative 2, or negative 2 equals negative 2. Yes, it works. But to be a solution, it has to work for both linear equations. So when I went over here, negative 3 plus 5 times y, which was 1, equals 2. Well, 5 times 1 is 5. So then negative 3 plus 5 equals 2. Negative 3 plus 5 is 2, so 2 equals 2. Yes, so we get our answer as yes. When I do number 2, same thing I'm doing. I'm going to input, switch my colors, 5 in for y, or I'm sorry, 5 in for x, and 2 in for y. So here's my equation, 2x, which becomes 2 times 5, minus 3y, which becomes 3 times 2. I have 10 minus 6 equals 4. 10 minus 6 is 4, so 4 equals 4. Yes, this equation works. When I go to my next one, 2x, well, I put 5 back in for x. Bennett. Sorry, my kid bumped me. 2 times 5 is 10. And I'm going to put 2 in for y. So 8y becomes 8 times 2. 2 times 5 is 10. 8 times 2 is 16. 10 plus 16 equals 11. Well, 10 plus 16 is 26. And does 26 equal 11? No. And because it's a yes here and a no here, one no means my final answer has to be no. Alright. When we graph, I got a lot of work. This is the one thing, don't get lazy on your schoolwork. Do all the steps, show all your work. So I had the equation x plus 2y equals 7. what I did was I rearranged it so I could get it as y equals mx plus b. Sorry, my computer screen's moving while I'm typing this. X. When I did that, I had y equals negative 1/2 x plus 3.5. Instead of doing 7 over 2, when I need that coordinate point, we're going to go ahead and solve. So it's 3.5. My slope was negative 1/2. Y-intercept was 3.5. And as you can see, I went ahead and I graphed that one in green. So this equation was in green. I went into the other equation, 3x minus 2y equals 5. Did that over here. And I found y equals 3/2 x minus 2.5. I was making sure I didn't make a mistake. But when I had a minus 3x, I divided by negative 2, so it gave me a positive 3.5 x. I solved, and I didn't write it down. I should have. But my slope on this one was 3.5, or 3 over 2, and my y-intercept is negative 2.5. So you can see here is my negative 2.5, there's my graph, and this is where we intersected. So I write down that coordinate point right where those two lines intersect, which was over 3 up 2. So my solution's 3, 2. Now you'll see in red pen, I went ahead and I went back to check my work. So I went back to x plus 2y equals 7, and I put in 3, which was x, and 2 for y. And I have 3 plus 2 times 2 equals 7, which comes out to 7 equals 7. So yes, it works. I go to the equation 3x plus 2y equals 5. And you'll see that work right here. And we find out 5 equals 5. Yes. So overall, I know my solution is correct. Do the same thing on each one of the examples. I'm only going to go through about one more of these examples, but each time I rewrite the equation. So I took this equation and I rewrote it as y equals x minus 7. Then I know my slope and my y-intercept. So I graph that, let's see, in blue. So there's my negative 7, and my slope was 1 over 1. Equation 2, when I solved it, came y equals negative 1/4 x minus 2. Graphed it. There's where we intersect. So that would have been coordinate 4, negative 3. Okay, so 4, negative 3 is my solution. We input that in for our first equation here. Negative 3 equals 4 minus 7. It comes out to negative 3 equals negative 3. Yes, it works. We go to our second equation. Negative 3 equals minus 1/4 times 4 minus 2. Comes out to negative 3 equals negative 3. Yes, it also works. So that's my solution. You'll see on each one of these, I've tried to color code them so it's easy for you to follow around. I take each equation, okay, and I write as slope, intercept form, identify slope, y-intercept, and graph, and then when I find where they intersect, that's my solution, and then I went back in red and I tested it out to make sure, does that solution work for both of them? Same thing on both of these. Solve the equation for y equals mx plus b. Graph. When I found where they intersect, that's my solution. And then I check to see if it's correct. If you had any questions over this and you're confused, please make sure you check with me.